This conference will now be recorded.
The problem is with my single screen. Apologies for that. Okay, now I can see it. Thank you for joining. This is probably this is the second meeting that we are continuing on this series. We will. I hope this time works for all of you. So, in the sustainability metrics, we are starting the data center efficiency metrics work stream. Basically, like the main theme is that if you look at our the sustainability project goals, we have a goal of delivering a roadmap to increase standardization of measurement, disclosure, and metrics across IT products, and including calculation. And in order to achieve that, we need to define the metrics that need to go along with it. That is the main purpose for this work stream. And expanding on that, what we are trying to do in this work stream is that we want to define efficiency metrics across data center. And you can basically say, like, we want to define something related to the energy related items. And energy related items need to make sure that all the performance or power, IT power, non-IT power need to be combined. So what we are saying here is define data center infrastructure efficiency metrics, as well as measurement and disclosure requirements, and also mechanism. So all the three things we want to comprehend in this work stream. And also we want to partner with the software developers as well as data center operators to create ecosystem so that you can broadly make this available and deployable. Initially, we are thinking about bi-weekly, but I scheduled for a weekly one because we want to make some progress initially. Then after that, we could probably move to bi-weekly cadence. And the other part of it is if we can really like define a draft requirements for energy efficiency calculations within the IT equipment, then we can either make it available or present in the OCP Global Summit this year. Any questions on that? If no questions, then we want to go into the PUE augmentations. I think I will give the floor to Mohan to present. Good, Mohan.
Thank you, Sammy. Can you give me sharing rights? You gave me, but I think it went away
I
again.
gave you. I need to switch that. Let me check. It's the
Oh, perfect. Yeah, I see.
Thank you.
Right. Good morning, everyone. So, wanted to talk about what are the sustainability metrics we're talking about, and maybe in the given time we may not have the ability to get into all of them, but at least get into deep dive into some of them and see where we want to go. So there are a number of metrics that are used for sustainability today, right? Ones that you're probably very familiar with, PUE, and similar one for water called WE, global warming potential, called GWP and carbon utilization efficiency called CUE. So it's not that we need to go do any extra work defining these things. These have been defined by either by Green Grid or by some other organization. So there are definitions for these guys. What's the gap that exists? And I'm very glad to see Jeff, because this is very similar. If I were to draw a parallel between the role that like DMTF does in terms of setting mandatory standards, that's the kind of role that Green Grid plays in setting standards. So they do a good job of creating these standards that serve sustainability well. What they do not do is then say what specifically applies to you and how do I compare two values, right? This is even right. So it's when you're given two values, let's say PUE, and one is smaller than the other, is the smaller value better? And that's the question that we need to answer in this work group. And then as we answer those, there are some additional uh, metrics that we need to create, and we'll talk about them, for example, for infrastructure and for networking, where they are just swept under data center today, and it would do us well to go look at them separately as technology emerges. So with that, I just want to get into why I make the statement on what's the problematic, what's the problem, and what's the opportunity for this project with respect to PUE, right? So, as I said, the definition is very clear. Everybody knows what the definition is, but it's how do you measure and how do you report? There is OCP in other projects, for example, in manageability project, has done an excellent job of creating profiles that say, if your OCP profile, you must do these things, right? It doesn't matter what the standard specs say. So essentially, it's tightening the spec uh, to say that you have to do these things, and that's kind of where we need to take sustainability to. The standards are great, but they don't really, like, let's take PUE. They don't really tell you how many times you're supposed to. What's your sampling period? Like how long you measured? Did you measure for? Did you take one measurement and say that's your PUE? Did you measure it over 10 weeks, 10 months? Uh, don't know, right? Where you don't get to see that. How many samples did you take within that sampling period, right? Uh, if it's like, let's say, over a month, did you take 10 samples in that month, or did you just take one sample? And we'll talk about static versus dynamic, which is did you do a spreadsheet analysis or did you actually measure this thing? And then um, are you reporting, because it's supposed to be a data center metrics, and what is a data center is a good thing to define, right? Otherwise, what you're getting is truly a partial PUE, right? You just leave out the troublesome portions of your data center and then report the PUE, and then somebody says, oh, mine is 1.1, and somebody says mine is 1.2. You can't say 1.1 is better than 1.2 because we don't know the boundary that you're measuring across is the same. And then closer to silicons and platforms, it's a it's a measure of IT, how IT energy is spent, and unfortunately there is a proportionality to what load you place on the system when you made this measurement. So you could change the load, and you could come up with different measurements based on how you want to report. In fact, I won't name any names, but I've talked to uh, partners, shall I say, that have said that they have in their IT department when they have to support their PUE and they have downward pressure from the management. It's like, hey, we are starting to measure PUE. You need to do the right thing. Right thing meaning you need to essentially make sure the load is at the right place, so PUE is not all over the place, right? But that's not the. But then there is no point, right? I can you want 1.1, I'll get you 1.1. You want less than 1.1, I'll get you less than 1 point by manipulating. So how do you come up with some guidelines and guardrails that where we can look at the measurement and say you truly have contributed to this goal of sustainability. And last but not least, when they started this PUE back around 2006, 2007, something like that, you're lucky to have a PUE of 2, right? So you're basically you're 50% efficient, if you will, right? Now, everybody that reports PUE, like if you look at the big data centers, hyperscale data centers like, Microsoft or Google or whatever, they all report close to 1.1. And PUE is the ideal number is 1, right? There is nothing about below 1 in the way it's defined, right? Once you get to 1, you basically are asymptotically done. So how do you represent data center efficiency as your metrics are closer and closer to 1, right? So maybe we need to go away from this. I mean, not that PUE is a bad metric, but maybe there is something else that's needed here. And beyond beyond PUE as we look into the future. If everybody's going to report close to 1, then you kind of take away the value of the metric in some sense. And the other one is um, there is what is a server is undergoing redefinition, right? So for example, you go to immersion cooling or you go to liquid cooling. The role of server fans changes substantially in presence of those type of thermal solutions. Now, what's inside the data center boundary and what's inside the ID boundary, if that is changing, then you need to comprehend that change because PUE was defined in the good old days of, I mean, like I said, about more than 10, 15 years ago when there was very clean. You got a metal chassis with one or two sockets and memory and NIC and CPU fans and CPU power supply and everything all self-contained uh, rack server, right? And when that is changing, thanks a lot due to what OCP is driving, for example, in DCMHS. What does it mean to say something is an IT load? Is is something that we need to undertake essentially. And over over the period of this year, it should be our goal to take on all these challenges. So, as I said, yeah, there you go. So defined in 2007 by Green Grid. It, uh, it's the ratio of data center energy to IT energy. So you put in a megawatt and uh, let's say 500 kilowatts went to your IT load, then your PUE is 2, right? So half as efficient as you should be. Uh, and it's only meaningful in terms of the changes that you make to the data center uh, infrastructure, right? So what you want to change is not IT load. What you want to change is your data center, the left portion of this picture, uh, the power and cooling portion of this picture. So essentially, how much are you wasting in your power delivery, and how much is your cooling costing you, right? If you change those two, then you're influencing PU in a meaningful way because the ideal you want to get to is uh, every ounce of every kilowatt hour of energy that's coming in. If it's going to IT, essentially you get to one. Uh, and as I said, like hyperscale, they do a fantastic job because their ability to pick their geolocation, right? They go to high deserts like Oregon and Washington, and they are able to use some cooling solutions that essentially minimize uh, their cooling load. So therefore, they track to much better PUEs. But overall, as a world, our global average PUE is around 1.5, which is not too bad from probably around 3 or so where we started out with. I don't think I have the graph, but it has come down substantially, and it's trending to flatten out as a whole. these days. So let's talk about some of the limits, and I'm not telling you something that even the folks that wrote the PUE spec were not aware of. So another way to rewrite the PUE equation is it's 1 plus the total non-IT energy divided by the IT energy. So however you want to think of it, uh, let's say you have a great data center, and I mean you have a data center, let's say, right? You have PUE of 1.5, let's say, let's just make up numbers, and you you said, no, what, I'm going to be sustainable, and you swapped out all the IT hardware you had for more power efficient hardware. Now, if your power efficient hardware essentially uh, consumes less energy, that means your denominator goes down. That basically means you get a higher PUE, not a lower PUE, which is contrary to what you would expect. And this is something that's well known and documented. So if you if you only make changes to the IT load in a way that your your whole goal is to reduce your overall consumption, essentially you're measuring across two different IT loads. If you do that, then the PUEs are not comparable. That's the way to think of it, rather than that your PUE went up. So your goal should be to at all times to keep your IT load constant. So your measurements can be compared. Otherwise, you run into very contrary problems like this one. By the way, feel free to stop. And if this is all old hat to you guys, we can skip ahead to the discussion as well. I don't have to go through this if this is all very familiar material to all of you. Any feedback so far? Should I just keep going? Or
Yeah, keep going on.
all right, thank you. So the other thing that's happening, especially with vendors like ODMs and some vendors, they report, hey, my PUV is going to be 1.05, 1.07. And you see these fantastic numbers reported by folks these days, and you look into it, uh, and what's happening is, uh, so and by the way, this is also it's not like again, this is all allowed by the spec. What I'm showing you literally is allowed by the spec. There is a concept of partial PUE, right? If you take the entire data center and think of it as zones, and within any given zone, you can say what's the energy that's going inside this boundary, and what's the IT load within this boundary, and that ratio is called partial PUE. And folks conveniently report partial PUE, except that they don't tell you that they're reporting partial PUE. So sometimes you look at numbers and go, wow, this is amazing numbers. How are they hitting this number, right? In some sense, when hyperscalers are able to report these wonderful numbers like 1.1, everybody's, wants to catch up to them. So they say, I mean, I'm 1.12, but it's, are you really? They are not, except that they essentially are reporting the PUE of a zone in the data center. It's not very clear that they're reporting a PUE of a zone, right? So even though it's very well specified, if you do that, you have to say you're reporting a partial PUE. But again, there is no enforcing function, so everything comes out as PUE, and this is the other problem that we have overall in terms of how PUE is measured. And then, so sorry, I jumped the gun on the hardware vendor. Many hardware vendors like ODMs, like some of the thermal solution providers, they report PUE, and their PUE, they they don't own a data center. So what are they reporting? It's essentially based on a spreadsheet calculation. So if you go from us into data center facility, you would see PUE numbers all over the place. And you would see there is no Microsoft, there is no Google, there is no Meta there. So what are these numbers? It's some vendor essentially saying, if you deploy my solution, and I'm telling you what is the coefficient of performance for your cooling is going to be, and based on that, I'm going to be hitting a PUE of X. Not a single measurement was ever taken in doing this. So, and again, we really should call this static PUE and distinguish it from what's being measured. And only if you truly have measured at a data center level and put out the measurement should you be allowed to call a PUE. And again, intuitively, this all makes a lot of sense. It's really the 1849 gold rush, if you will, right? Sustainability all of a sudden became important. So everybody wants their share of whatever this is. So, and they all start reporting values. So this is where we need to go and tighten what's allowed and what's not allowed through this forum. Okay, so I talked about measurement, and and I said, only data center measured PUE should be allowed to report. Okay, where exactly do you measure in the data center? So that again is a question that we need to answer. So the specification actually allows you to measure it. So incoming power, data center incoming power, that's easy, right? Some utility company is providing power into your data center. You measure how much power is coming in. That's one place you just measure it, you're done. But what's IT load and how do you measure IT load? Uh, there are different options. So as the picture on the left shows, you could be measuring the power at the UPS uh, that goes into the panel uh, that feeds into all your IT data hall, right? You just measure that at one time, and that represents the measurement for the entire IT load. You could measure that at the power distribution unit in going into each of the racks or rows uh, in your data center, or you could measure them at the IT load itself, and then essentially give that. So as you can see, you could measure it any number of ways, but where you measure makes a difference on what PU you come up with. And so the more sophisticated you are and the better equipped you are, the better PU you're able to produce, right? Because somebody who's got the resources uh, to go out and produce the PUE at L3 is producing a much better PUE than somebody that's only producing a PUE L1, right? Because the PUE L1, the losses at the data center level are all being attributed to your IT load. So if you really want accuracy, you want to be at L3. But again, when you see the reporting, do you know it is L1 versus L2 versus L3? No, you don't, because there is nobody that's saying, what did you measure it at? I would like you to specify, right? In other words, PU needs to have this like a massive list of subscripts, right? To be able to say what this is. And by the way, since Jeff is here, allow me to go on a tangent on manageability, right? This is one of the problems we have with uh, with server management in general. How much power is a server consuming at any given point is the easiest question to ask and the hardest question to answer, right? And we are here because elsewhere they've done a fantastic job of designing protocols for how you go out and get power measurement if you implement it. But do you implement it is another question. And without at the L3 level, everybody actually implementing and exposing the ability to measure power, we have no chance of getting L3 power measurements. So that is another thing we need to undertake. Maybe this is essentially forcing a sustainability profile to manageability folks to say you are if you want to be a sustainably oriented server in a sustainable data center, you must report your power, right? Because I think the wording now says if implemented, this is what you do, even in the OCP profile, and we got to do better than that. We have to say, if you're a sustainability profile, there is no choice. You must implement it so we can do L3.
Yeah, I agree, Mohan. It's definitely time whether we, and I think we can have that discussion between here and the hardware management group as to, are those requirements, do those just need to be a baseline for an OCP managed, or just an OCP, stamped device, or do we create a separate profile that says, hey, these are the things that you have to have if you want the OCP sustainability, design for sustainability check mark? It's certainly one.
Exactly. Keep going, Jeff. Go ahead.
I mean, I think it's certainly one of those two things. If it's, and I think we can test the waters on that, and certainly we can create our own profile and then see, number one, like, well, how, what kind of resistance do you get from folks to meet those requirements? And then I think it's probably for the larger OCP community to decide, are these measurements and being able to, to complete all the sustainability goals, is that a fundamental tenet, or is that an option, right? So I know where I would fall on that, but I think that'll be probably a question for the larger community. But the good news is the work we would do here to define what those things are is the same, because we can, whether we publish that profile as a standalone thing or we cut and paste that stuff into the manageability baseline, that's a 5-minute difference on our part.
Right.
That's a good point. Also, we need to see, is there any cost added to the devices itself, right?
Well, it's always going to be cost, right?
It's always cost added, exactly.
Yeah,
I don't think it's.
Yeah, and Mohan, I think so I think there's a couple things there. I think it's as we've gone through some of the same questions, it comes down to kind of 3 buckets of information. There's it's the kind of the what's the current state of what's the current state going at, what's your power consumption at the moment, what's your energy rate. Then there's a question of how much data is kept at the device versus how much are we assuming that a higher level piece of software is gathering, and that's kind of where the big questions I think come in for cost and storage and so forth. And then the other one is that we don't want to lose track of this, and it's this diagram I think is a perfect one to explain this, and that is we also need to be able to find the pathway of where the power, how the power is delivered. So I've been working quite a bit in the redfish models to ensure that there is, that there are definitions for, how to show the electrical connectivity, from device to device happens, so that you can trace, to say, but go, Mohan, if you put your pointer somewhere on that diagram, point to one of those L3 IT loads. Figure out where are they in that chain and how do they, how does that get bubbled up? Because until we're not going to be able to wait until every single device has L3 level, the coverage at the device level. We're going to want to be able to to make some buckets out of those things and say, okay, look, I've got, I can't get you the stuff at those mechanical switch gears, but I can take the measurements upstream from that, then at least I can categorize it and define it. So the long lead time and long lifespan of a lot of this gear means we're I don't want us to wait a decade to be able to get to that
Absolutely.
granularity, right? So at least being able to report where the stuff is and how it gets bubbled up is really important for being able to actually get something done sooner rather than the next decade.
Absolutely. I think there is a pragmatic portion of this where we say, okay, at least if I can get you off from L1 to L2, I moved the needle.
Yep.
Where would I want to be? We want to be at L3, but you're absolutely right. So some of the telco equipment gets kept for like 7 to 10 years. There's no chance I'm going to be able to influence that by retroactively adding some protocol that doesn't exist there. But at least what we can say is, to looking forward, you will not produce anything that doesn't meet the L3 requirement, so we can tighten what we are trying to measure here.
Yep. Yeah, and some of that basic location data, I mean, that's why it's important we get that stuff into a profile, because it's not difficult to implement it. But it does, it means somebody has to do some software, but it doesn't add hardware cost. If you've got a managed interface, then adding some place for a user to type in a few values, or for hopefully something that's a little more automated can come and set, to tell me what power outlet this server is connected to. It's basically just providing a field on a GUI, and the value through the API, and then a little bit of non-volatile storage to store some values. So we're talking about bytes here, not megabytes.
Exactly. Right.
So Jeff and Mohan, does it make sense if we should take a look at the Redwiz, the
We should
power
drive.
related items?
We should drive. So I think Jeff proposed two options, right? Where my head is at is to say we should create a sustainability profile and say, if you're going to meet the sustainability profile and get certified as a OCP sustainable product, here is all the stuff that you have to meet. And then we can just throw in all these requirements, like your server must supply your power measurements at any given point. And we should make that a goal. And it's easy enough to, I mean, I'm sure Jeff can write that easy and in his sleep, right? I mean, we already say if implemented in OCP manageability, all we are doing is tightening that a little bit more and saying you must implement, and then essentially put the right wording in there so they don't play with numbers like you see happening here, right? It's an actual measurement, right, that you're reporting. Right, Sandy, like PSMI and everything has existed for decades. I mean, it's very, very sad that we are here.
Well, I have this conversation often, and it is funny that we've been talking about this, and we have a lot of the power measurements have been around for decades. But what folks need to understand is that the reason those power measurements have been around for literally about 20 years, coming up there at least, it was to ensure that a system was staying within the power and thermal envelope of the enclosure where it was at, meaning the rack or the rack circuits, or the cooling capacity of a particular device. And since these IT loads were highly variable, you couldn't go with nameplate ratings or even some derated versions of those and have anything that looked realistic. So you either were horribly over provisioned on power and cooling, or you ran the risk of being horribly under provisioned. So that's why these live measurements actually got into the products. It was not for energy savings. It was for being able to stay within the power and thermal envelopes of the environment. So that's why it's there. And now, did it absolutely get, it absolutely got used in the brownout and the rolling blackout periods in the early 2000s. It actually absolutely got used to help explain and to help manage the way through some of that stuff. But it was all very much looking at instantaneous power, and it was trying to watch for those peaks and valleys, at very granular levels, to make sure you didn't miss something because you didn't want to go trip a breaker somewhere. But that doesn't translate necessarily into actual, energy consumption and kind of long-term averages of things. So the data can be there, but it was done for a different reason, but it certainly uses the same hardware.
Yep, completely agree. This was to do power capping and things like that.
Exactly.
Yeah, precisely. But it's coming in handy for other reasons as well at this point.
So I'm kind of wondering on this point here, right? Is it possible either Jeff or you want to find somebody or to bring in what is available today, and we need to have some discussion on what need to be added? Jeff, you can bring it in one of the meetings. It'll be good. We can have a discussion.
Sure. Yeah.
Sure. Thank you.
All right. So since Jeff touched on IT energy and IT load, so let me go there. So when people report PUV, the other thing so let's say one is reporting PUE1 as shown in the picture. The other is reporting PUE2, and PUE2 is less than PUE1. Which do you think is the better one from a sustainability standpoint? If you say PUE2, then the picture should tell you a different answer, because what PUE2 is measured under is a IT load that was modified to be higher as they did this same data center, different IT loads. Now all of a sudden you're getting a different PUE value. So, and like I said, without naming no names, this is what I hear happens because, again, IT manager works at the privilege of some CIO, and the CIO has to report some number that makes his or her company look good, right? So when you see a number, you have to look behind the cover so much because, like, just from this picture, you can't tell what number are you reporting from. What number should I take to the bank, right? From what's being reported, because there are so many parameters that you can play with to get the number to be favorable to you.
So Mohan, the red is not reported.
No, so I just crank up the load. You say, like, let's say you say, Mohan, I need to report PE for our data center at Intel. I say, okay, Sammy, I'm going to put a huge load on the IT next couple of days. Let's go ahead and measure it. Because your denominator is higher, your PV comes out lower.
Okay, got it. It says how much efficiency or
Right.
the load changes efficiency or the
Exactly.
numbers.
So the spirit is that you measure on average is this where you are at. That's what you need to be measuring. But if you every time you measure, you essentially crank up the IT load, then you're going to come up with a very favorable number. But that's not your impact on the planet. That's what I'm trying to say.
Correct.
Right. So if you're going to use this for sustainability, you're kind of doing a disservice to yourself and to your fellow humans by doing that. Right. So now, so if you look at IT power versus utilization, right? Unfortunately, it's not linear, right? So there is an active idle point, and then there is a 100% utilization point, and this is what Jeff was talking about. That there's so lot of the metrics that exist came into being. A lot of the control knobs that exist came into being because they're so worried about tripping the breaker, so they needed to measure to figure out how not to trip the breaker. But when it comes to reporting PUE, um, as I showed in the previous slide, you don't know if they're reporting PUE 100 or they're reporting PUE at 40% utilization, and it makes a huge difference to what you do with the number. So what should be the right number? The right number should be whatever it is at average data center utilization, right? That's on average where you typically tend to be at, right? Uh, Reporting this on uh, prime day or like some peak event day for your data center is really not the way to go, because especially if that peak is artificially induced. So we really need to pick a number, and the reason I pick 40 is between 40 and 60, the dotted lines that I've drawn is the natural band for any average data center. So what we need to do as part of this work group is to also say, yeah, then tell us that this is at IT utilization at this place, right? Somebody may come back and argue, no, my IT utilization is truly at 70 or 80. We can have that discussion, but for most data centers, they sit between 40 and 60. So we can pick a number, right? As Jeff was saying, in fact, nobody believes nameplate, so they used to derate it to like 50%. So if you want to say you should report at 50% load, that's fine. But at least we'll consistently get a number we can look at and say, I know exactly what you're consuming, therefore I believe what sustainability you're accomplishing here.
So Mohan, in addition to picking a number where the reporting need to happen, do we also need a cumulative number how much really actually consumed, or is it a hard thing to impose? Meaning
Sorry.
cumulative, meaning like how much it's consumed for the or a month or a quarter or year.
Oh, I'm coming there, Sammy. Give me 1 second. So now first, so if you wanted to have like a write up on what we would write up as a document, right? These are the things that we need to include, right? Is your PUE measured at a data center level? The answer has to be yes. It's actually measured, not some static. Otherwise, you're a static PUE. Does your PUE actually comprehend the entire data center, right? Not some circle that you drew around some specific IT equipment. And the answer has to be yes. Otherwise, you're partial PUE. And Sammy, where you're going, what's your sampling period? Your sampling period better be, we should say your sampling period be in the order of months, and we should say it's minimum of 12 months if you're a true data center, because otherwise the other trick that you can play is, so people use adiabatic cooling. What that means is that, hey, I'm in a climate like, I live in Oregon, lots of data centers in Oregon, because the climate is cool most of the time, cool and rainy most of the time. So maybe a month it gets hot, and in that month they essentially use evaporative cooling, uh, or maybe that month the chiller kicks in. But if you only measure the months where like November through March, when absolutely nothing is running, and you say my PU is 1.03, you're like, yeah, it is. Your cooling is, it's not representative of your true cooling budget, right? So if you go through an entire 1 year of 12 months, then you've gone through all the seasonal changes, and now you're seeing a much better, you know, picture of what your data center is actually doing, as opposed to measuring just the favorable months for you, whatever they are, right? Uh, so yes, I mean, absolutely, we have to go specify. And within that, how many samples should you take, right? So again, here the spec itself has done a good job. They define basic, intermediate, and advanced. Basic means you have to take it either weekly or monthly. I forget what intermediate is, and advanced is you take every 15 minutes, which may be a little too much in terms of data storage and whatever, right? So we may have to say you have to at least do basic. Essentially, you have to measure monthly. You don't get to, like I said, some of these vendors putting out numbers based on static analysis. It's like, okay, it's one measurement, right? So you really want to say you need to be basic, which means you're measuring every week or every month, and you're averaging that number, as opposed to um, picking the perfect time where your numbers are going to be favorable, reporting the number that's favorable to you. And then we just talked about IT load, and you have to say what's your IT load at any given, like what's your utilization, right? We need to say, okay, at 40% utilization, 50% utilization. Uh, I'm not here to prescribe a number, but I'm saying you need to pick it in the band where you're usefully sitting most of the time, because that's your burden on the carbon footprint, right? Um, And then there's another thing that I should have put the picture in. There's another thing, right? So all of this equations that I presented so far kind of implicitly assume electricity was the only thing that was coming in. This is not true. Um, it may be a true statement for many places in the United States, but this is not true overall, right? There are other sources like natural gas, steam, chilled water, you name it, that are also energy sources that are coming in. So we need to make sure that uh, that it's truly reflecting utilization of the power, right? However you get to that, it should be PUE inside the P part is ill-defined, if you will, right? Because when they define these things, data centers were at a pretty nascent stage, and you don't blame them for what they define. but we should just, instead of, in our head, we should not think of it as power, we should think of it as energy, right? Essentially, whatever the total source of energy you put in, and the ratio of that to the IT energy is what PUE represents. So the total source of energy could be anything, right? It doesn't have to be electricity alone. And in fact, uh, there are conversion factors that have been specified for, you know, what does, because you have to weight them, right? So if electricity is one, yeah, is if I'm doing natural gas, is that also one? Is it ISO? And there is some weights that have been defined, and again, we need to essentially refer to already established standards. Uh, Atomic Energy Agency, uh, of the US or the European Energy Agency, they all define these numbers. I've shown some of them in the examples. Again, I'm not here to prescribe this is the number, but we need to point to some source and say, this is how you'll calculate. So it's a weighted average as opposed to just a simple calculation like I've been showing so far. So, and once we can turn this into a flowchart, at the end of the flowchart, what comes out is a number that we can truly compare and believe in some sense.
So, Mohan, this is going to be another important factor, right? I recall Shruti asked in the last meeting, after doing all this work, what are we going to be able to influence our outcome of is going to be, right? If you're running in a no carbon emission energy place, even PUE is higher, it's not going to be that much matter, right? If your energy that you're taking is going to be more carbon intensive,
Yep.
then PUE matters more.
Yep. Exactly. So great lead in. So there is another. Uh, so why are we so heavily focused on PUE? Because PUE leads to CUE, which is carbon usage effectiveness. And that's really the ratio of how much carbon dioxide did you emit as a data center to the how much IT energy did you use. But as you can see, if you just rewrite that equation, you get CUE is actually a product of carbon emissions factor times PUE. And carbon emission factor, as you're saying, Sammy, is dependent on your energy source. If your fossil fuel, like a coal burning power plant that was supplying you, you're going to have a number greater than one, right? And and if you're a green power source, right? Let's say you're solar or wind or geothermal or whatever, then that number is going to be smaller. So at the end of the day, you could influence what you're doing by also changing your carbon emissions factor. Absolutely, and that's the other thing that we need to do. But we need to get to how do you report your carbon emissions factor? Given uh, I, it's its own discussion in itself, and there is a lot of policy questions that come into picture here, right? Because in some sense that's a data center level problem, right? So I didn't take it on, but you're right. That's the reason to do that. So you could have a horrible PUE, but you're offsetting all of that by saying, well, I'm entirely based on solar. So your CUE is still a good number because you're not polluting the planet. Okay, that's one way to definitely look at it. But you would think that you would want to minimize both so you get to the smallest number possible,
So,
right? Because
sorry, one
none of this
question
is
here.
zero. Go ahead, Shruti.
Sorry, I'll let you finish. I just had a quick question after that.
Yeah, my point was that it's not like if you use solar or wind, it's the carbon emission factor is zero, so it gives you a carte blanche to just uh, pollute the planet, right? So you're still dealing with a finite number, which means you still have to pay attention to PUE.
Okay. So my question was actually if you just go to the last slide that you had up.
Previous slide.
Yes.
Yeah.
So in the last row related to, the energy source itself, we are basically now saying that the impact of the energy source is folded into this PUE itself, right?
Right.
That's what we are trying to say. But then
Right.
PUE is no longer just the efficiency of the DC, right? So I'm
It is
just
still, yeah.
map that in my mind. Like, we are not indicating purely the efficiency of the DC anymore. So, like, I guess you were also pointing out that, okay, you could actually improve your energy source and show an improvement in the overall number. I think you are basically saying then PUE itself will improve if I improve my energy source, like if I went to more renewable energies.
Oh, no, no. Here, that's not what I'm saying. Here, notice in the electricity, it's just one. It doesn't say whether it's renewable or non-renewable. What I'm saying is that
Oh,
so
okay.
you cannot play tricks here by saying I brought chilled water directly from the district, because let's say your district is something that gives you chilled water, and you just use that to cool your data center, and you go, there you go. My data center energy is low. I have a low PUE. It's like, no, nice try, because you your chilled water was produced by chilling somewhere else, right? Which cost energy, which you're not accounting for in your PUE calculation.
Okay. I see. Okay. And then one other question. So where we say, number of samples, obviously large number of samples is good. But then if suppose we are having a, good number of samples, whatever, whether it's daily or something like that. In that case, here we are also specifying that we want the same IT load at each of the sample. But considering that, in a realistic DC, if we are taking a large number of samples, the IT load obviously is continuously changing. And if it is a large number of samples, that will actually reflect the real IT load anyways.
Fantastic observation. Truly fantastic observation. If you're measuring it once a month, you can say, hey, measure it at. So what we have to do is to tightly specify, if you're measuring it, measure it at about the same time when you take the sample. You don't do one sample at 8 a.m., another sample at whatever your peak number is. So pick a time, right? So 12 noon, another sample at 3 p.m., right? Don't do that. If you're going to pick the same time every day and measure it, that's fine. And then if you go into the advanced method of sampling, where you're sampling every 15 minutes, then I have no questions on load. You keep your load whatever, because essentially what will happen is you will end up tracking to, where's my graph? Oh, I don't have my graph. Yeah, you will end up tracking to this. There may be some samples that are literally at idle, some samples that are at almost 100% utilization, but overall average, you're going to be in the middle. So then I'm not going to ask you to specify your IT load if you're actually you're sampling at every 15 minutes.
Got it. But then we also need to maybe give guidance of what is that number of samples. Like, is daily the limit
Exactly.
beyond you don't need to, or is it? Yeah.
Precisely.
Okay.
Precisely. At what point you can no longer play games with manipulating numbers. This is where we need to define that and put it in. Excellent question. Excellent observation. Precisely. What I was assuming the pessimistic number, Shruti, that you're reporting by monthly, and I was trying to say at a given month you got to measure it at a given load, and preferably that load should be when you're sitting in your average point, not just pick every month. You don't pick your high point and give us that number.
Okay. Yeah.
Right. And
Quick,
as you can see, yeah, go ahead, Sammy. I
quick
think we're running out
time
of time.
check. You're on the top of the
Go
hour.
ahead.
How many more
You
slides
can.
do you have?
I can stop here, Sammy. It's probably a good stop. Oh, it's 8 o'clock.
Yeah.
I
Do
can
you want
stop here
to,
soon.
do you want to continue
So
in the next meeting? Or?
yeah. So I want to go into. So far, I've talked about what we want to do with PUE, and we need to talk about what other metrics need to exist, and we can do that next time.
Okay.
Let me stop. Thanks for the time, Chuck. I
And
completely lost track.
thank you, Tim. I was waiting for intros because I thought like if I get few more people, we can have a more intro. I think we know both Shruti and Jeff. Maybe Jeff and Shruti, if you can, and Kobe, if you can just introduce yourself, might be good. Otherwise, we can meet next week. Looks like Kobe left too. Or we can have intro.
We can do it next time. Sir.
Yes.
Okay.
Because I have to run to a meeting, so I don't
Okay,
want
sure.
to leave in the middle
Thank
of
you,
the
Tim.
introduction.
We'll looking
right.
forward to
Okay.
see you next week.
Thanks,
Thank
everyone.
you.
Thanks, folks.
Thank you.
Bye.
Yeah. Bye bye.